We're gonna start with a table that shows the difference between current and potential difference when the resistors are connected in parallel and series. As you can see here, in a series connection, the current is the same, while in a parallel connection, the current divides. Potential difference divides in series, and then potential difference is the same in parallel connection. I'm going to draw a simple circuit diagram showing resistors connected in parallel and in series. Okay, there we go. We have two circuits, of which one is connected in series, the other one is connected in parallel. So what we are going to do here is that we're gonna trace the flow of current in both circuits. We already know that when comparing the positive and the negative terminal of the battery, we know that the longer one is positive and the shorter one is negative, meaning this is negative, negative, positive, positive. So positive is this side. Then the current is going to flow in this direction, just like that. And then it enters this resistor, this one and that one, and then it will come back to the battery like this. That's the flow of current. Current did not divide here, it just went through these three resistors connected in series here. So there is no division of current, but the potential difference is not going to be the same, because when we use the formula V equals I R to calculate the value of the potential difference here, the current is the same, but the resistance is not the same. If we use 5 here, let's take this is 0.5. If we use 5 here, we are going to get 2.5 as our voltage, and then if we use this, we're going to get a different value here, and if we use 20, we're gonna get a different value, meaning that the potential difference divides is not the same. Okay, then we come to this one. This is the positive terminal of the battery. Then we're gonna follow this path just like that. But when we reach this point, the current is going to split up. Current is gonna follow this direction. Some of the current will take this path and some of the current will take this path, as you can see. And then they are going to meet again here at this point, and go as a single unit like this until the current reaches the negative terminal of the battery, just like that. So what you must know is that when we are talking about the relationship between current and resistance, is that the relationship is inversely proportional, meaning that if we are to change or make current the subject of the formula, we are going to divide both sides by R, and we're going to get I equals V divided by R. These represent that the two are inversely proportional. They oppose each other, meaning that when one of these two variables increase, the other one decreases. So what influences current is the resistance. When we increase resistance in the circuit, the current will actually drop, just like this. It means that if we were to decrease the resistance, current was gonna go up because they are antagonistic to each other. So which one is going to get a high current between these three resistors? The 5 ohm resistor. This is going to get high current. Why? Because the resistance is low. The lower the resistance, the higher the current. this is going to get a very small value of current because it has a higher resistance. So they are not going to get even current just like that. So this is what you must apply when solving questions based on this topic. I'm going to draw a simple, okay. Now let's talk about calculations. How do we get the effective resistance in both parallel and series circuit? Effective resistance simply means total resistance and stuff, just like that. So let's focus in series. How do we calculate resistance here? You just add the resistance. Like I'm going to say RS, of which is series. RS is going to be R1 plus R2 plus R3. R1 is 5 ohm, 5 plus 10 plus 20. This is going to give you 35 ohms. Just like that. That's the effective resistance in series. What about parallel? Parallel is R1. It's RP equals 1 over R1 plus 1 over R2 plus 1 over R3. If we had two resistors, we were going to say 1 over R1 plus 1 over R2, just like that. And then you make the inverse of this, just like this. This is the formula. So let's calculate the effective resistance here. We're gonna say 1 over 5 plus 1 over 10 plus 1 over 20 to the power of negative 1. 2.86 ohms. 86 ohms. This is what we are going to get as our answer. Now let's compare these two. When you look at this circuit and this one, comparing the two, we have the very same magnitude of resistance. It's 5 ohms, 10, 20, 5, 10, 20. But the effective resistance is not the same. What can you conclude? It means that when you add a resistor in series, you are actually increasing the total or the effective resistance, because this value is going to increase if we add another resistor here. But then when we come to this one, if you add a resistor here or in parallel, it's going to decrease this value. Let me show you an example. I'm just going to add another resistor and give it the magnitude of 100. Just add on this 1 plus 1 over 100 and see the value. As you can see, the value dropped from 2.86 to 2.78, just like that, meaning that when we add another resistor, we are decreasing the total resistance. Now, how can we increase resistance in this one? We must add another resistor in series to increase the effective resistance. What about when you want to decrease? It means that you must remove a resistor here so that you can decrease the total resistance. What about here? How can you increase resistance here? In order to increase resistance, you must remove a resistor. When you remove a resistor, this value will increase. Just remove any resistor here, try it with R1 and R2, remove R3. You will see this value is going to increase. But when you want to decrease a resistance here, you must add another resistor so that you can decrease the total resistance. So that's what you must know when it comes to electric circuits. The relationship between current versus resistance, potential difference versus current, just like that. I want us to compare between these two circuits. Let me say this is circuit A and this is circuit B. Which circuit is going to have a high total current? Circuit B is going to have a high current. Why? Because it has a lower resistance. And we said that the higher the resistance, the lower the current, meaning that this one is going to have a smaller value of current because it has a higher resistance. This one is going to have a higher current because the resistance is low. Just like that. Okay, another question. How can you increase current in this circuit? You know that in order to increase current, you must decrease the resistance. So it means that we must add another resistor in parallel so that the total resistance can decrease, and that will lead us to a higher current. What about this one? How can you increase current? Yeah? In order to increase current, you must decrease resistance. It means that you must remove a resistor so that we can obtain a lower value of effective resistance, and that will lead us to a high current. So these two are not the same. In order to increase current here, you must add a resistor. Here, you must remove a resistor. Just like that. That's what you must know. Once you know this, it means that you are not going to fail to answer questions on this topic. I'm going to pick a question from the exam paper, and then we try to answer the questions that are there. I've extracted this question from a grade 11 question paper. We're going to try to answer all of these questions using this circuit diagram. I'm going to start with the tracing of current. As you know that this is the positive terminal of the battery. So we're going to trace the current. You know that it moves from positive to negative. So it's going to go like that. There we go. Oh, so it's not going to go through this because this is a voltmeter and it has a very high resistance in such a way that it won't allow current to pass through it. So current is going to continue like this, and then it goes like that. Then we have another voltmeter here. So it means that it's going to continue like this and reaches this point, of which is the cross section. Current is going to divide. It's going to go up, down, and continue like this. So which resistor is going to have a high current? We are not sure now because we don't know the resistance of R. So, but between these two, we can tell that this is going to have high current because it has a lower resistance. And then current carries on like that and then meet again at this point and then start to flow as a single unit, just like this, until it reaches the negative terminal of the battery, just like that. So this is an ammeter. This is an ammeter of which measures the current. Or these two measures the potential difference. They're talking about a switch. This is a switch, as you know that this represents a switch. And then EMF simply means the maximum energy that this battery can supply per coulomb's charge. It means that the maximum potential difference of this battery is 12 volts. Just like that. And then this represents a switch. When the switch is closed, V2 has a reading of 3 volts, meaning that this is going to be equal 3 volts. The first question says calculate the reading on the ammeter. When you look at this, ammeter is connected in series, meaning that it's going to measure the total current of the circuit. Whenever an ammeter is connected in series, it means that it's going to measure the total current of that circuit, because the current moves straight from this terminal to the ammeter and then continues like that. So we're gonna look for a resistor that is connected in series in order to get the current, because the current that is going to pass here is the very same current that is going to pass here, because this is connected in series. So we're gonna use this to calculate the current. But in order to get the current, you must at least have the potential difference and a resistor, because we have this formula that says V equals I R. This is current, resistance, and potential difference. We already have resistance and we need current. It means that we must have the potential difference. But when we look at this, they told us that V3 is equal to 3 volts, meaning that from 12 volts, we already have 3 volts used in this one. What does that mean? It means that the voltage here, or the potential difference on R, is 3 volts, 3 volts here and 3 volts here. Why am I saying that? Because we said in parallel connection, the potential difference is the same. So it means that the reading on all these 3 resistors is going to be 3 volts. So from 12 volts, where we already have 3 volts here, it means that the remaining potential difference is for the resistor connected in series. So we're gonna say 12 minus 3 volts, and then this is going to give us the potential difference of V1, of which is going to be 12 minus 3 is gonna be 9. So this is 9 volts in short. V1 equals 9 volts. V2 equals 3 volts. How are we going to calculate this? We are going to use a resistor that is connected in series, because this ammeter is connected in series. So I'm gonna say this is 6 volts, by the way, 6 ohms, by the way. I'm gonna say V equals I R, for which resistor, of which is R6. So what is the potential difference on R6? We said it's 9 volts, and then I'm going to say 9 equals I. What is the resistance? 6 ohms. 6. And then you know that you're gonna divide both sides by 6, and this is gonna give you I equals, because this is going to cancel with this, and then you're gonna get 1.5 amps, because current is measured in amperes. So this is your current, meaning that the reading on A is equal 1.5 amperes. So this is the first question. The second question, calculate the total resistance of the circuit. How are we going to calculate the total resistance? We must calculate the resistance in parallel connection, and then add the resistance in parallel with this one. But since we do not have the resistance of resistor R. That's going to give us a problem. But however, we have another option that we can use in order to get this. Since we know that we have this formula, V equals IR, we already have the potential difference of the parallel connection of which is 3 volts, and we have the current that is going to pass through this. The current that is going to pass here is the same here, but it's going to split up. But combined, it's going to be the same as this one when we make these 3 resistors as a single resistor. So what are we gonna do? We're gonna say number 2, V equals IR. What is the potential difference? They said is 3. When we combine the current of this and this and this, is going to be the same as this one, because the current that is going to pass here is the very same current that is supposed to split here. We are going to take the parallel resistors as a single resistor. So this is going to be 1.5 multiplied by Rp, because we're looking for the magnitude of the parallel resistance. So I'm going to say this is Rp. Then we divide everything by 1.5. This is going to cancel with this, and we are going to get Rp as 2 ohms. It means that the effective resistance of the parallel connection is 2 ohm. The question was saying calculate the total resistance of the circuit. This is the effective resistance of the parallel section. So what are we gonna do now? We are going to say R total is equal to Rp plus Rs. What is the total resistance in parallel? Is 2 ohms plus. The resistance in series is 6 ohm. And then we're gonna say plus 6. The total resistance is going to be 8 ohm. And then we go to the third question, which says calculate the resistance of resistor R. Resistor R, of which is this one. We already have the total resistance of the parallel section, of which is 2 ohms. So it's gonna be easy for us to get the resistance of resistor R. How do we calculate a resistance in parallel section? We say Rp, this is question 3. Rp is equal to 1 over R1 plus 1 over R2 plus 1 over R3 to the power of negative 1. Rp we got 2 when we were calculating the parallel resistance. So this is going to be 2 equals 1 over R1, of which is 4 ohm, plus 1 over 6 plus 1 over R to the power of negative 1. This is going to give us 2 equals 5 over 12 plus 1 over R to the power of negative 1. To remove this, just put a root of negative 1, negative 1, negative 1, root of negative 1. And this is going to give you 1 over 2 equals 5 over 12 plus 1 over R. And then you take 5 over 12 to the other side, and you are going to get 1 over 12 equals 1 over R. Then you cross multiply this. R times this is going to give us R. 12 times 1 is going to be 12. So if you don't understand this part, just let me know in the comment section so that I can try to explain it using a different option. I don't want to make this video long, put in different options and stuff. So just tell me, then I will try to explain. So if resistor R is removed, what would happen on voltmeter V1? And then you have three options here: increase, decrease, or remains the same. And then you have to explain your choice. This one is now removed. I'm going to use this paper to close here. So it means that we are going to have a circuit like this when resistor R is not longer there. I'm going to give you a table or a template that shows the relationship between current and potential difference and resistance versus current. When we look at current and potential difference, you can see that the relationship is directly proportional. So let me just write the relationship is dP here, meaning that is directly proportional. And then why am I saying that? Because when the current is high, the voltage is also high. When the current is low, the voltage is also low. But when we talk about resistance versus current, when the resistance is high, the current will be low. When the resistance is low, the current will be high, meaning that the relationship here is inversely proportional. I'm gonna use IP for inversely proportional and dP for directly proportional. So these opposes each other. These are directly proportional, meaning that when you increase one factor, the other factor increases as well. To answer this question, if we remove this resistor, what is going to happen? Like I said at the beginning, that when you remove in a parallel connection, you are actually increasing the total resistance of the circuit. And then when we add in a parallel connection, we are decreasing the total resistance of the circuit. Now let's check on this relationship table. When there is high resistance, the current is going to be low. And when the current is low, the voltage will also be low. So in other words, when you explain this question, you are going to say, if we remove that resistor, number one, the total resistance increases. The total resistance increases, and when the resistance is high, total current will decrease. Total current decreases. And when we have a low current will lead to a low voltage. And then potential difference will also decrease. The potential difference is also going to decrease. That's the answer. So please use this. I've made this for you so that you can understand these things better. And then the answer here is decrease. Reason, these are the reasons. Because the total resistance increases, total current decreases, and then the potential difference will decrease. So this decrease is the answer to this question. I believe that you are understanding something. Thank you for watching. Please don't forget to subscribe